The lesson today is about vertical angles and linear pairs. Now, as you work through a recorded lesson, you need to pause the lesson so that you can write down the notes. I will briefly stop on a screen, but then I will continue on so that the recording is not extremely long, but you need to be pausing it so that you can do the examples. You need to pause so that you can write down notes. So interact with the lesson. You will have plenty of time to finish it. Okay, so the lesson, as you see, is lesson 2-4, vertical angles and linear pairs. The definition, vertical angles are two angles that are not adjacent and they're formed by two intersecting lines. Again, pause so you can write it down. Okay, to explain some more about this, yesterday we worked on things that are adjacent. So adjacent meant angles that were hooked together. They shared the same vertex. They had a common side, a common ray. So they were like right side by side. Now when you are looking at vertical angles, you want the two angles that are not side by side, formed by these two intersecting lines. So on the first diagram, angle 1 and angle 2 would be an example of vertical angles. Not vertical because one is on top, one is on bottom, but vertical because they are across from each other, they're not adjacent, and they're formed by the two intersecting lines, the same two lines. Second diagram, I could put a 1 and a 2 on that diagram. Those are vertical. If I go back to that same diagram, these two are vertical. So you do have more than one pair of vertical angles. Let me add one more line to that diagram. Now that we have 3 lines, we need to be careful which 2 we are using when we talk about vertical angles. If I put a 1 here, now trace those same 2 lines, number 2 right there would be vertical. Let's stick with that same diagram. If I put a 3, the 2 lines that make angle 3, as I extend them, would make red angle 4. 3 and 4 are vertical angles in that diagram. And if I would continue on, highlight now in blue, 5 and 6 are vertical angles. So you can have a lot of vertical angles. You need to pair up to make sure that they are formed by the same 2 lines. The next term is linear pair. Pause the presentation and write it down. Now to explain a little bit more, linear pair, it does say they are adjacent. So these do have to be hooked together side by side. And it says, and their non-common sides are on the same line. So let's look at this first picture. This angle is formed by these 2 rays, and then an adjacent angle right beside it, sharing this ray, then the other side. Notice these last 2 sides, I'll highlight, the one going to the right and the one going to the left. Those make a straight line. They're on the same line. That's what makes these 2 angles called a linear pair. The name of the angles, linear, notice line is in there, so that should be a reminder to you what a linear pair is. Together they make a line. Not just that there's a line in the picture, but if you go from the side of one angle all the way through both, that gets all the way around to a complete line, linear pair. So the diagram on the right, we've got angle 1, angle 2. Again, they are hooked together. These other rays are opposite. They make a line. 1 and 2 are a linear pair. Now you might notice the other diagram is the one that we just looked at with the vertical angles. This diagram also does have a linear pair. So if I would put a 1 here and a 2 here, those are a linear pair. If I switch and put the 2 here, those are not a linear pair. Those were vertical angles. If I put the 2 here, now again I have a linear pair. They're hooked together and form a line. If you have a ruler or maybe an index card, you can cover up part of the picture, and then it might be easier for you to see angle 1 and 2 are on the same side of the line, resulting in a linear pair. Okay, now I need you to get your tools from below your desk. You will be drawing a diagram and then measuring angles in the diagram so that we can discover the relationship for our upcoming concepts. So get the supplies out, and I need you to make a drawing on your paper, on your notes. I just need you to make an X, make 2 lines that intersect. I just have room over there, so that's how I drew it. You can have it tipped differently. Don't try and make everything look like a 90-degree angle. That's going to produce something that you don't really want. Now I'm going to pause for a bit, so you need to shut this off, but the directions are you need to grab your protractor and in degrees measure all 4 angles in this diagram. Measure all 4 angles with a protractor. Okay, start me back up when you're done. Okay, now if you will look at the results that you had, I know you're only looking at one right now, and it would work better if we had everybody to compare, but based on yours, do you have any angles that are the same? And if you do, which ones are they? You really should have this angle the very same as this one. They should have been exactly the same degrees. Another relationship is the one over here would be the very same as the one over here. In other words, the ones that are vertical across from each other, the vertical angles should have measured the same. If that didn't work, why don't you stop and get your protractor again and see what you did wrong. Ask for help from a teacher aide or sub. Another relationship that you should find, if you look at the angle of, or the degrees of this angle, and then the degree of the obtuse one right beside it, what do those 2 add up to be? They should add up to 180 degrees. And if you try that again, let's take the obtuse angle and we'll look at this one. Do those 2 add up to 180? They should. If we look at this angle and the one next to it, those 2 should add up to 180. And I think there's one I didn't do, but all of the adjacent angles should add up to 180. Why is that? Well, again, you've got a linear pair right now marked. If you go from one side through that angle and all the way around to the other, the far side of the other angle, that makes half a circle. That makes a straight angle, 180 degrees total. Okay, so even if that didn't quite work for you, here are your notes as far as what the relationship should have been. First one is a postulate. Remember, postulates you can't prove, but we would accept without proof. If we look at this one, we would have the straight angle total 180 degrees, and so that would help us convince ourselves that this is true. Again, pause so you can write the notes. Okay, to explain it again then, if 2 angles form a linear pair, they're supplementary. Let's consider a picture again of a linear pair. Here are 2 angles that are a linear pair. Okay, linear pairs form that straight angle, and the total degrees for a straight angle has to be 180 degrees. We have 1 angle, 2 angles, and together they would add up to 180 degrees. Isn't that what supplementary meant? So a linear pair of angles, they are supplementary. They're going to add together. So the measure of angle 1 plus the measure of angle 2 in this diagram is going to be 180 degrees. That's what supplementary means. Then the other thing that should have come out of that diagram was that the vertical angles were the same. Vertical angles are congruent is what the vertical angle theorem says. Pause to write the notes. Okay, so to look at this in a diagram, vertical angles, I'm going to draw two intersecting lines. I'm going to start with one angle. Let's go with this one being 150 degrees. Okay, now based upon what we just discovered, the linear pairs are supplementary. The angle just to the right, this angle would have to be just 30 degrees, because 150 and 30 adds up to 180. Now if I keep doing that, that 30 and the bottom angle have to add up to 180. So this angle would be 150. And go to the last angle. Again, a linear pair, 150 and 30 would be 180. Now if you look at the diagram, do you see the vertical angles that are congruent? These two vertical angles are the same degree measure. And then these two are the same degree measure. So vertical angles theorem, a theorem can be proven. So we can prove this one by using the linear pairs of angles. Okay, so now some practice problems. Whoops, I just used 30 degrees. So let's change this degree measure for angle 4. Let's make angle 4 38 degrees. Okay, find the measure of each angle in the diagram, and when it says give support for each answer, how are you figuring them out? Are you using the fact that vertical angles are congruent? Or are you using that a linear pair is supplementary? There's not just one right answer, but I want you to think about what are you doing. Okay, so pause so you can find each angle measure and the support for each one. Okay, as you work through this one, again, you might do this in a different order than what I did, but let's see if you can follow my thinking and if you get the same degrees that I do. First thing I did was use vertical angles. Vertical angles are congruent, so angle 2 was also 38 degrees. Then I could look at angle 4 and angle 1 are a linear pair. So for angle 1, they had to be supplements. So 180 minus 38, 142. Angle 1 is 142 degrees. And then if I know that one, I can do its vertical angle, angle 3, is also 142 degrees. So the way I've talked it through, I used vertical angle theorem, then I used linear pair postulate, then I used vertical angle theorem again. Could have been done in a different order. Find the measurement of each angle in this diagram, and again, come up with the support for each one. Pause so you can solve. And the degrees for each one, I'll do this one differently than last time. Let's start with a linear pair. So I'm going to get angle 2. Knowing that 2 and 3 together would make a linear pair, 180 degrees total, because linear pairs are supplementary. That looks like 55 degrees. Angle 2 is 55 degrees. Now I'm going to do vertical angles to find both of the others. So angle 1 is also 55 degrees. Angle 4 is 125 degrees. Now the diagram has more angles. Just be careful if you're using vertical angles, which angles are vertical of each other. And if you're using a linear pair of angles, you need to be just looking at two angles. So in order to do that on this diagram, you'd have to combine a couple angles together and treat it as one angle to find the other linear pair. So I'm going to pause and let you do some figuring. Okay, I would guess that you did a couple of them pretty easily. You probably got angle 6 to be the same as angle 1, 22 degrees, because those two are a linear pair. They're formed by the same two lines. Now angle 4 is going to be vertical with angle 3, 42 degrees, and I'll highlight it in a different color. Those two were formed by the same two lines. Now you might have gotten stuck. But angle 2 and angle 5 are vertical angles. If we figure out one of them, we will know the other one. So how do you get one of them? Okay, if you can mentally block out part of that picture, notice that 4, 1, and 2, all those together come around to a straight line. If we would pair 1 and 2 together, or 1 and 4 together, that's a total of 64 degrees. That angle and angle 2 would be a linear pair. So to get angle 2, 180 minus 64, 116 for angle 2. The same would be true for angle 5. And notice what all 4 angles add up to be, or excuse me, all 6 angles add up to be. That should total 360 degrees. There are 360 degrees total around any single point, like in a whole circle, 360. It said give your support. I think I mentioned vertical angle theorem a couple times, and then I used linear pair theorem, linear pair postulate, and then vertical angles again. Now we'll throw in some algebra. Find the value of the variable, find the measure of each angle. Okay, as you look at the picture, let's see, are they vertical angles? No, they're not across from each other, they're side by side. Do they share the same vertex? And they have a side hooking them together. Would the side that's not hooking them together, would those two make a complete straight line? Yes. We have we have a linear pair of angles here. So these two angles will be supplementary, which means they add up to 180 degrees. So that's how you're going to write your equation. You're going to add those up, set it equal to 180 degrees. So again, you need to pause so you can do some solving. So I'm going to start with 3x plus 25, added to 2x, has to total 180 degrees because of the straight line, straight angle. Okay, pause and solve. If you got your steps, it was 5x plus 25 equals 180, subtract 25, that would be 155. Divide by 5, I think 31. Now the directions said find the value of the variable, which we just did, then find the measure of each angle. So substitute back in. 3 times 31 is 63 plus 25, 88, I believe. Okay, then 2 times x, 2 times 31 is 62, and notice that 88 plus 62 what did I do wrong? Oh, I didn't calculate this up here right. This is not 88. Back up. Good thing I checked it. I made a mistake. 3 times 31 is 93 plus 25. 93 plus 25. 118. Okay, let me check it again. 118 plus 62. Good, I got 180 degrees total. That's what it was supposed to be. So sorry for the mistake, but it's good to know what you need to do to check and make sure you have the solutions correct. Okay, on this picture now, it's possible that we have vertical angles in this diagram. It's possible that there's a linear pair of angles in the diagram. Which one are the ones that I marked? It's a linear pair. They are adjacent and their non-shared sides are on the same line. So if you look back at your linear pair postulate, it says linear pairs are supplementary, which means they add up to 180. Okay, 3x plus 24, and then add on 78. That should total 180. The linear pairs are supplementary. Okay, pause so that you can solve. I'm going to double check myself by some calculations this time. Okay, so 78 and 24 add together 102. So 3x plus 102 equals 180. Subtract 102. 78. Divide by 3, 26. I'll substitute in and make sure that I did this right. Okay, so 3x, 3 times 26 plus 24. How many degrees is that angle? 3 times 26 plus 24. 102. 102 and 78 together is 180 degrees. So I did that one right. Supplementary angles because they're a linear pair. Okay, almost the same diagram, but notice, I'm going to flip back. Notice the angle, 78, I switched which angle and made it 108. Now, are these a linear pair of angles still? No. The two that I'm using in this diagram are the vertical angles. Vertical angle theorem, vertical angles are congruent. Congruent means their measures are equal. So on this one, you should go 3x plus 24 is equal to 108. Vertical angles are congruent. 108 minus 24, 84, divided by 3, 28. Let's plug in and make sure that that's right. 3 times 28 plus 24. 108. Vertical angles are congruent. I just noticed in my directions it said find the measure of each angle. So these are both 108. What's the angle off to the right? Remember there's a linear pair going on. So 180 minus 108. 72 degrees here, 72 degrees here. I think maybe I skipped doing all that on the last diagram, so sorry about that. Here's another one for you to look at. Find the measure of each angle, find the value of the variable. What relationship do these two angles have? Are they vertical angles or are they a linear pair? These are vertical. Vertical angle theorem. Vertical angles are congruent. They have the same measure. So they are equal. It's the linear pairs that add up to 180. So again, solve. I subtracted 2x from each side. I'm adding 24 to each side. And I'm dividing by 2. Now let's find each angle. I'm going to switch colors for you. Okay, 4 times 17 minus 24. 44 degrees. 2 times 17 plus 10. That's 34 plus 10. This is 44 degrees. Okay, those vertical angles are congruent. What are the other two angles? There's a linear pair, so they have to be supplements. So to find this angle, 180 minus 44, 136. And vertical to it would be the same degree. Okay, let's review a little bit before you start on your assignment. It says, describe a linear pair of angles and how are their measures related? Describe vertical angles, how are their measures related? Pause so that you can answer those questions. Now the answers, a linear pair are two adjacent angles, so side by side, that together make a complete line. When you go from one ray all the way through both angles to the other ray, it makes a straight line. How are their measures related? They are supplementary, meaning they add up to 180 degrees. Number 2, vertical angles. They're formed by two intersecting lines. The vertical angles are the angles that are across from each other, formed by the same two lines. How are their measures related? They are congruent, which means their measures are the very same. They are equal. Okay, I think that's the end of the lesson. Find out what the assignment is and complete that for the next day. Thanks.